Factoring. This is a big topic in algebra, and honestly, I like it a lot. So this is just the introduction. We'll start with kind of the basics, and then as we move on to other sections, we'll get to the more and more complicated ones. But today, I hope is pretty straightforward. So hopefully you remember the distributive property. It was the way that we could multiply a polynomial, like x minus 3, has two terms. So if it has two or more terms, it's a polynomial. One term is a monomial. So as you remember, we do 2x times x, which you see right there, minus 2x times 3, which you see right there. 2x times x is 2x squared. 2x times 3 is 6x. Now we've talked about this recently. Numbers have factors. For example, 6 has two prime factors, and that would be 2 and 3. And just in case you're thinking, wait a minute, well, 1 and 6 are also factors. That's true, but 1 and 6 are not prime factors. And the point is, 6 is the result of multiplying these two factors together. So 6 is the composite of multiplying the two prime numbers, 2 and 3, by each other. So just like numbers have factors, algebraic expressions, things like what you see here, can also have factors. So as we can see looking at this problem, 2x squared minus 6x has two factors. When the problem started, we saw those two factors. It was 2x and x minus 3. And just like 2 times 3 results in 6, 2x times x minus 3 results in 2x squared minus 6x. So just like 2 and 3 are factors of 6, 2x and x minus 3 are factors of this. So factoring an algebraic expression is working backwards to find its factors. So honestly, especially at this level of factoring, you can almost think about it like we're doing the reverse of the distributive property. The distributive property allows us to multiply two things together to get this result. Factoring allows us to start here and work backwards to figure out what two things multiplied to make that happen. So let's think about the one we did. So 2x squared minus 6x. So our question is, what did 2x squared and 6x have in common? And I'd encourage you to think about the numbers and the variables as two separate pieces. So 2 and 6, they're both divisible by 2. So that makes 2 one of their factors. This has two x's, and by that I mean x times x. And this just has one x by itself. So they both have at least one x, because you got to make sure each of them have whatever you're saying is a factor. So I can't say x squared, because while x squared is a part of this one, x squared is not a part of this one. But x is part of both. So since they have factors of 2 and x, that means 2x is the expression's greatest common factor. It's not its only factor, but it's the common factor that's the biggest for these two. So we can do the distributive property backwards to find the factors of 2x squared minus 6x. So the way I have it written here is what was the answer in the original is now the question. Since we know 2x is the greatest common factor, we can say, okay, if I pull 2x out of that, what's left over is x. Because I pull the 2 out, I pull one of the x's out, that leaves me which is x. And if I divide 6 by 2, I get 3. Divide x by x, I get 1, so it just cancels out. So it's splitting it up by taking the greatest common factor out of each piece. And then we know if this piece has 2x, and this piece has 2x, I can pull 2x out front, and what's left is x minus 3. So another way you could think about it, the distributive property is done by multiplying. Factoring will be done by dividing. So another way I could approach this is say 2x squared minus 6x. I find the greatest common factor, which is 2x, and then I say, okay, I'm going to pull 2x out front. And to figure out what's left once I pull that 2x out, I'm going to divide. So 2 divided by 2 is 1. They just cancel out. X squared over x. Hopefully you remember the rules. When we divide, we subtract the exponents. 2 minus 1 is 1, so it's x to the first power, minus, we divide this one by 2x. 6 divided by 2 is 3, and x divided by x is 1, so they cancel out. So we end up with 2x times x minus 3. So let's just kind of make sure we get the greatest common factor element down first. So first, just look at these numbers. We want to think, okay, what's the biggest number that goes evenly into all of them? So one way you could approach this, you don't have to do this. You can just think through it. That's fine. But I might just look at the smallest number and say, okay, things I know go into 12 are 2, 3, 4, 6, and 12. Well, 2 does go into all of these, but we need to see if there's a bigger one that does too. Okay, 3 goes into all of these, so that means 2 is not our greatest common factor. I look at 4. Okay, well 4 goes into 12, and 4 goes into 36, but not into 18. So I just have to cross that one off because it doesn't go into all 3 of them evenly. Okay, now 6 does go into all 3 of them evenly. So 6 is a possibility, meaning 3 is not big enough. 12 goes into 12, and 12 goes into 36, but not 18, so we're going to cross it off for that reason. So whether or not you write all this out, you could just kind of start with a small number and think, okay, what numbers could go into that? Will they also go into these two? And whatever one is the biggest is your greatest common factor. So as I think over here on number 2, I first think of the numbers, 18 and 27, and I think, okay, what numbers that go into 18 will also go into 27? Well, 18 is too big. 9 goes into 18. Oh, and 9 also goes into 27. So 9 would be the number part of the greatest common factor. This has a single y. This has y times y. So since this only has 1, we can only pull 1 out of both of them put together. So our greatest common factor here is 9y. Okay, so to factor out the greatest common factor, we do the distributive property in reverse. Now once you've factored, if you want to check your answer, you can multiply it to see if it gives you the original. I'll do that on 1 or 2 of these, but not all of them. I don't plan to require you to do that, but I do want you to know you can do that. Okay, well we just looked at this on the previous page, 18y and 27y squared, so we already know its greatest common factor is 9y. So I'm going to put 9y out front. Then 18 divided by 9 is 2. Y divided by y is 1, so I don't have to put anything there, because just 2 times 1 is 2. 27 divided by 9 is 3. Y squared divided by y is 1. Y to the first is what I should say. Y squared divided by y is y to the first power, so it just gives us y. So I'll show you on this one. Now this is our answer. You can check your answer by distributing. You can say, all right, 9y times 2 is 18y, plus 9y times 3. 9 times 3 is 27. Y times y is y squared. And look, that matches that. So that proves we did it the right way. Okay, here on number 4, we first want to look at the numbers. What's a number that will go into all 3 of those? Well, that would be 2. It can't be any bigger than the smallest one, so 2 is what we'll go with. This has 2 a's. These have 1a, so we can only pull out 1a because these don't have any more to give than that. This has 1b. This has 2 b's. This has 3 b's. So we can only take 1 out because that's all that one has. So that's our greatest common factor, 2ab. So I'm going to say 4 divided by 2 is 2. I took one of those a's out, so I left one behind. I took the only b out, so it's gone. So again, 4 divided by 2 is 2. I took one a away, leaving just an a. I took the only b we had, so it's just 2a. 8 divided by 2 is 4. I took its only a away, and I took one of its b's, so it still has a b left over. 2 divided by 2 is 1. You can write 1 if you want to, but you don't have to. we take away the only a it has, a divided by a. We took away one of its b's, leaving 2 left over. So this will be 1b squared. Okay, number 5, we want to think first with the numbers. What's the biggest number that would go evenly to 21 and 15? Turns out for this one it would be 3. Now we look at the variables. Well, they have no variables in common. If they have no variables in common, then we just pull out a number. Only a number is its greatest common factor. 21 divided by 3 is 7, and the b didn't change. 15 divided by 3 is 5, and the a didn't change. So that's our answer, but again, if you want to check it, we can do 3 times 7b is 21b, 3 times 5a is 15a, and that matches what we started with, so that proves we did it correctly. Okay, here the greatest common factor is 2c, because they're both even, and they both have at least one c. 14 divided by 2 is 7. It took one of the c's away, leaving one left. 2 divided by 2 is 1. C divided by c is also 1. So you have to put a 1 here. We can't just make a term disappear. So on this one, I didn't have to write 1 when I said 2 divided by 2, because there was still a b squared left behind. So b squared and 1b squared mean the same thing. But we can't just act like there's nothing left, because we divided. 2c divided by 2c is 1. So make sure you don't just let a term disappear, even if it cancels out completely. Okay, last one. They're all divisible by 2. They all have at least one j. They all have at least one k. 12 divided by 2 is 6. Its only j is taken. One of its k's is taken. So one's left. 6 divided by 2 is 3. One of the j's is taken, leaving one left. The only k is taken. 2 divided by 2 is 1. We took away one of the j's, leaving one behind. Took away one of the k's, leaving one behind. And you could distribute that, and you'd find out we have the same thing we started with at the beginning.